Okay, I'm going to try and attempt to explain to you the questions that were on the sheet about electronic configuration and how they relate into information with the group number and the period number. So I'm going to start by looking at the periodic table first of all and just explaining a few of the key concepts that we've got on here. So what's not labelled on here are the groups and the periods. They have written the number on, however, and along the top here is the group numbers that we have for the elements. The group number is going to relate back to the electronic structure. Okay, so that's the group number. Now periods, they don't label on at all. Periods come down the side, and that is effectively the row. So the groups are the columns. I'll write that on there, columns, and the periods are the rows. So row 1 is the one that people most commonly write incorrectly because they forget that helium is over here, okay, and you've got hydrogen, which would normally appear at this point here. So that's row number 1. So get rid of that. Period, or row number 2, 3, 4, 5, and so on. So that is our rows and columns, or our groups and periods. So let's look at one of the elements now and look at how this relates into electronic structure. So let's take a look at boron. Boron, the element, it says 11, 5. 11 is the mass number, that's the number of protons added to the number of neutrons. And 5 is the atomic number, that's just the number of protons, which also happens to be equal to the number of electrons. So therefore boron is going to have 5 protons. Because it's got 5 protons, it will also have 5 electrons. And then to work out how many neutrons there are, you would need to do the 11 take away the 5, which would leave you with 6 neutrons. Once we know that information, we can then work out electronic structure. Now, electronic structure is just the idea that in an atom you've got your nucleus in the middle, and then whizzing round the outside you've got electrons, and they exist in shells. But shells aren't a physical thing that you can see, touch or feel. It's just an area of space that the electrons occupy. And the rule is we always start working from the inside shell. You can have a maximum of 2 electrons in that first shell, and after that you can have 8 in those shells afterwards. Or we can write it out starting from the inner shell first of all, 2 in the first shell, maximum of 8 in the next, maximum of 8 in the next, and so on. That continues. So we work from the inner shell next to the nucleus towards the outer shell. And that is one of the ways of writing it out. So let's go back to our example that we had over here. What colour should we go for? Green. So if we put boron in the middle, and we're trying to work out how many electrons it should have, boron has got 5 electrons altogether. That means you start from the inner shell, so I'm going to put 2 electrons here. That means we've used up 2 from 5, that means we've got 3 left. We can't put any more on the inner shell, so we move to the next shell. We know that the maximum number that we can have on the next shell is 8 electrons, so we've got 3 left, so we just put those 3 there. And it doesn't matter how you write these electrons. If you want to write them in groups like I've done, or if you wanted to space them out and put them in different places, so you want to put one there, one there, one there, doesn't matter, as long as they are on the shell somewhere, that's what's important. That's boron. Let's have a look at another one. Let's have a look at magnesium. So magnesium is nice and easy, 12, 24. That means it's got 12 protons because of the number 12. Because of that, it also got 12 electrons. And because 24 take away is 12, 24 take away 12 is 12, it's also got 12 neutrons. So that's nice and easy. But we're going to look at the electronic structure for it first of all. And I'm going to do it over on the side here. So we know that we've got 12 electrons to play with. So I put magnesium in the middle, and in that first shell we know the rule is maximum of 2, so it's got 12 altogether, but we can only put 2 in that first shell. Afterwards, we now know we've got 10 left, so we need another shell. We can have a maximum of 8 in this shell, so I put the 8 in. Oh, that's not right. 10 take away 8 is 2, so I've got 2 left. So another shell, and I put the last remaining 2 there. And that's all you need to do each time. Work from the inner shell and work your way out. Remember, it's max 2, then 8, then 8, then 8. Now I can write this out as well. So magnesium, starting from the inner shell, has 2, then 8, and then 2. So that's the way of writing it out. Boron, if we go back to this example here, had 2 in the first shell and 3 in the next one. So that's one way of writing out the electronic configuration. Instead, like you did in the table, rather than writing out the individual or drawing the individual pictures. Now let's link that back to groups and periods. The group number, remember this is the bit highlighted in yellow at the top here, actually tells you how many electrons are in that outermost shell. So if we go back to boron, boron had 3 electrons in that outermost shell. And that makes sense because it is in the third group. So that means that it's going to have 3 electrons in its outermost shell. So providing you know what group something's in, you can very quickly work out what the number of electrons are on its outer shell. If we look at the period number, this tells us something different. So the period number for boron is period number 2. You can see that boron has got 1, 2 shells, or 1, 2 shells. So the period number is going to tell you the number of shells in the electronic structure. Let's relate it to magnesium. Magnesium had 2 in its outermost shell, these 2 here, and that makes sense because magnesium is in group number 2. Magnesium has in total 3 shells, 1, 2, 3, and it's in the third period. So that's how those numbers relate back to there. So you can very quickly pick out an element. For example, if you were doing an exam question, let's just say I picked out phosphorus, and I'd very quickly be able to tell it's in group 5, so I'm expecting it to have 5 electrons, E minus means electrons, on its outer shell, and it's in the third period, so I would expect it to have 3 shells. And if you draw it out, you'll find that it has got, if we add up 15 electrons, 2, 8, 5 as its electronic structure, which adds up to make the 15. Hopefully that's useful to you. If it isn't, or if you've got any more questions or further things you want me to explain, then please just let me know.